All right. When it is fresh and early, 9 o'clock this lovely Wednesday morning, and I am so excited to welcome you back to AI Summer. As you know, this week that we are talking about programmatic implementations of LLM-based solutions. My name is Cheryl Bell. I am a senior data scientist here at the DSI, as well as an assistant professor of the practice of CS. You all know this, but just in case you don't, that's a little bit about me. Of course, I am joined here by my colleagues, my other instructors in the course who can help you if you need some assistance. I'm joined by Dr. Jesse Spencer-Smith. He is the Chief Data Scientist at the DSI and the Interim Director. Also, Epi Petulante is here, Miranda Shirk, and Umang Chaudhry. So if you need them, if you need some assistance, we are here to help. Also, remember that your colleagues are here to help. I really loved it on Monday, how active everyone was in the chat. I think that was really great. So please continue doing that this week. All right. So again, today, we are going to be building on what we learned on Monday, but generalizing it a little bit more. So as you know, on Monday, we talked very specifically about the different kinds of messages that we need to use in order to chat back and forth with the OpenAI API. And so we learned that there are some different kinds of messages. So let's see. Let me make sure that I can access these tabs. We're going to have the smallest little quick quiz. All right, let me make sure I can see all participants. There we go. Oh, that's interesting. It's a different view of that. All right, so listen carefully. All right, so the first question, and what you're going to do is you're going to use your reactions. So go ahead and find that tab on your screen. And what we'll be using is a green check and a red X. It's going to be a true, false question, okay? So true will be green check, false, red X, okay? So true or false, the main types of messages that we use when chatting with the OpenAI API are system messages, user messages, and assistant messages. True or false? Not meant to be a trick. Green check, true, red X, false. All right, beautiful. I see that we are coming to a conclusion together. True, we have three types of messages that we normally use with the OpenAI API. Those are system messages, which we use to configure the behavior of the overall LLM system whenever we're chatting back and forth with it. We have user messages. Those are the ones that the user or whomever is using our system, that's what is sent to the OpenAI API, and what is returned from the OpenAI API is an AI message, assistant message, something that shows that the assistant, who is not us, has said something back to us. Excellent, excellent. All right, let me see if I can clear all feedback. There we go. All right, now question 2, also not meant to be a trick question, okay? True or false? Green check true, red X false. True or false? Whenever we are using the OpenAI API, the OpenAI API itself manages the chat history. In other words, we can send one single message to the API, and the API alone will manage the rest of the chat history. All we ever send is one message, and the API manages the entire history of the conversation. And this is specific to the completions API. True or false? Green check, true, red X, false. All right, it looks like the red X's have it. Would anyone like to explain explain their answer? And you can just go ahead, you can either raise your hand or you can unmute. Sure, somebody's feeling brave out there. Why did you answer red X? Why did you answer false?
I can give an answer. So the main reason I said no was because I remembered, staying away from the jargon that I'm not comfortable with yet. I remember when we were programming, we would program the entire conversation we had from the beginning till that point, and we would add to it. And I just remember you emphasizing many times that you couldn't do that. So that's my reason.
That is a great reason, and that is the exact answer. So very, very well done. The answer is false. Whenever you are using the chat completions API, there is no management of chat history. If you send questions or answers one by one, all that's going to happen is it's going to behave as if these are just completely separate conversations. Whenever you want to have a conversation, so which includes a chat history using a completions API. So that's what we were using with OpenAI. Then you have to send the entirety of the conversation as the context. So very, very well done, people. Very well done. That's 2 learning objectives. Let me show you one more of the last learning objectives, just following up and finishing up what we talked about the other day. Oh, let's get there. Nope, that's the wrong one. All right, so yesterday we went through this code, and we're not going to run any code right now. This is just finishing up what we were talking about yesterday. Some things that I just wanted to quickly highlight. Sorry, I should have rolled to this point. I'm making everyone seasick. So here, okay, we were talking yesterday about what it means and why we might want to use an API instead of using directly the user interface that's available, because it's awesome. We love it. So again, what we said was, and we can see here that actually the LLM completion part is a very small part of an entire sort of application. So here, this is an example of one way in a smaller application you might try to manage chat history. So what we have done is use our Python programming, and we've made this function called getAssistantResponse. What it does is it essentially receives that new user message. It receives the entire history of the conversation. We have this parameter about whether we want to update the chat history, and of course we have the model name. So again, here, this is a little tiny part. So this is our chat completions. As you recall, we passed in the model name. And now we're going to just programmatically add to the chat history what the user said. And so you know that we have to have our object, how it has to appear to fulfill our contract with OpenAI's API. So we add this next conversational element, and then we send that to the API to get a completion. Now, once we have that completion, we can update the chat history. We don't have to write manually every single line. This is a programmatic implementation of how we just update that chat history. We can return the actual answer as well as that updated chat history. So here you see the other half of the actual functionality. If you were to run this right now, you would have a very like command line-y sort of interface. So what would happen is right now, we're just going to have a system message, and we are going to initialize our chat history with that system message. This line right here is basically accepting input from you, the user, in Google Colab. And what you'll see is like a little bar just like pop up here, and you'll just start typing. And so you'll say something like, give me an example of a Python of a Python dictionary. What will happen is we'll go into this loop, we'll print what I just wrote. Then we will call this function getAssistantResponse, where we pass in that chat history. At first, again, it's just going to be the system message. And then we're going to pass in the user input and that chat history, which is just going to be this first system message. And then our function is going to do the work, and it's going to return the answer, which we'll print. And we'll do this forever and ever and ever until the user writes exit, and then we're done. And here you see an example of that. A second example, like perhaps a step up in terms of implementation, is when we decide to add even more functionality to our system. So here you see a more likely implementation, not that this is the implementation, but this is something that someone might come up with in order to even more robustly manage the chat history. So what this is some Python programming, right? So Python. In fact, most of this was generated by ChatGPT. And so what we have is this new class, a class. Essentially, when you create objects of classes, they are their own little objects. So we could create one chat client, which would have its own information contained to it, another, and another. So here what happens is we initialize this, again, with our system message. We call these individual functions related to this particular class, which is basically where, we need to add a user message to a conversation. These two ways are how we are managing that conversation. So we'll whenever we want to add a message and call the completions API, this is the function that we've written to make that happen, specifically a method we've written. And so here, the same thing occurs. We have our message history. We append this. So this is how ChatGPT likes to receive, the OpenAI API likes to receive new messages. And then we call the completions API, at which point we have this. This again is looking really familiar because we have the chat completions.create model messages. Perfect. The rest of this functionality is just things that help us when we're trying to program or trying to create a full solution. So again, this is just a small part of the entirety of the things that you can do. If you run this, what you'll see is there'll be like this Gradio interface. You don't see it here, it's not running, but with a few extra little tiny lines, we have a whole user interface. It has chat history, a message box where you input information, and then whenever you click enter, this respond function is called. You see the add user message that we were just talking about, and then we update our user interface with the new conversation. So here, again, just emphasizing that this is just a small component of a larger system which you may wish to create. This functionality actually is very close to like the base ChatGPT functionality. So go ahead and give it a run if you haven't had the opportunity already. But very interesting, nice application. This is something that you can actually host publicly. You see a URL here, but you can put it on Hugging Face Spaces and you will literally have an application that can run. All right, so then let's talk about what we'll do today. And so let me go ahead and send that over. As you know, we're going to be in the AI Summer repository. So as you can see, this is what we did on Monday. And this is what we'll be doing today. I'm super excited. Just as a reminder, okay? So there is one workbook, which is the workbook. So it has some blank areas in it where we will code together. The solutions notebook, which is like the one I just opened, it has all the solutions in it, every single one. And so you don't have to worry about like programming anything. You can listen and just execute, or listen and just read. Whatever you need to do to manage your learning, you can have both open. Maybe if you fall behind, you just say, I'll get to that and try that again with the videos, which will be available. Or you can just literally just start out with these solutions. Whatever makes you happiest, go ahead and do that. All right. So again, today we're talking about RAG. We're talking about all the RAG, so much RAG. We're talking about the individual elements of RAG. We're talking about how we can evaluate RAG. We're talking about just like a lot. So let us click on this LangChain RAG. As you know, this is just GitHub. When you see the Octocat, it's just GitHub. There's nothing that really runs. It just enables us to be able to look with our eyes at the code, or with our ears if we're using screen readers. Then we can click this Open in Colab badge. This Open in Colab badge, again, is actually giving us a computational environment in which we can work. So we are going to go ahead and click that one. Actually, I'm just going to drag this one down just in case we need to do something a little bit different. All right, great. So it looks like we're there. What we're going to start out with doing is just go ahead and run this. We won't do that today. Let's just go ahead and run this cell. This is going to take just a little bit because there are some of these packages here. Again, we're ordering these packages from Amazon. Amazon sometimes takes a little second to deliver. So we are going to go ahead and start running this. Oh, someone said, I think they said something really good. Yes, 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 yes. So actually, thank you, Shane. What we want to do first is copy to drive. What you may notice is if you try to save this, what's going to happen is it's going to be like, I can't really save that. Sorry. So go ahead and start with copying this to drive, and then you'll be working on your own copy. Thank you, Shane. All right, so we're going to go ahead and get our little orders from Python Amazon. And so whenever we're copying to drive, what we can do is click this button. And this will enable us to directly copy to drive. And it should open up in its own little tab.
So could I ask, when you copy to drive, then whatever change you're making is the version only that's on your drive, right?
Yes.
Okay, and then you can later on access it by going on your Google Drive. Is that?
Yes.
Yeah.
Yes.
Yeah, I wasn't sure if it's temporary or if it's gonna stay.
So when you copy it to drive, it's on your Google Drive. I love that question because so we haven't really gone over the full functionality of Google Colab, but it very much is Google's Colab. So it has strong integrations with its own set of systems. If you look at this little folder here, what that is where sort of your, like if you were, today we're going to be using PDFs. If you wanted to use your own PDF instead of what we will be using. So if you have something on your computer, you can click and drag it over here and it will make it available to this workspace. But when you close this tab, that PDF will no longer be in the workspace. If you wanted it to stay in the workspace or you wanted it to stay accessible, what you could do is put it into your Google Drive and you can mount your Google Drive, which makes it actually makes all of the folders on your Google Drive available in this computing environment so that you can access them directly. And so it's actually a really nice way, like if you're working with other people on projects, to be able to like share data. All right, so we are still installing. We're going to make it past it. We're actually just going to go ahead and run this and run this. Those will both run after this is completed. Do remember that you still do need your OpenAI API key. And as a quick reminder, the way that you input that, we already made there. The way that you input that is using this key. They do carry over from previous sessions. So wherever you saved that OpenAI API key, you want to paste it here, making sure to call it OpenAI _API _key. Exactly the syntax, not lowercase, not uppercase, not dashes, not different words, because we actually reference it very specifically by this very specific set of symbols in this notebook. All right, delightful. So now we're going to talk about LangChain. So something that's actually really exciting with starting with the OpenAI API is that it does tell you a lot about some of the different kinds of messages that we can use when we're talking back and forth with an LLM-based system. And so you will see that again in LangChain. LangChain is a framework, and you can see here that it's like a bunch of things. It's like a suite of tools that allows us to implement these LLM-based solutions. So on last week, you heard Jesse talk about RAG. You heard him talk about agents. You heard him talk about tools. All of these things are possible when using LangChain. Do keep in mind that LangChain isn't the only LangChain out there. There are other implementations of this functionality that you can use. There's like Llama Index, Haystack does a little bit more, but we're going to use LangChain today. It is it is developer friendly. And not only do they give you, the actual API, they also have a lot of reference documents and a lot of things that you can read to understand what is going on. And they also give you great understanding of other things that you can do to help your LLM-based system perform a little bit better. So here you see LangChain Core. Actually, I'm just going to go to, yes. Okay, it opened a new tab. Delightful. So what I just did is I just clicked on this link. That's where this page, that's where this comes from. And we can take a look. So this is LangChain, the getting started page, the LangChain docs getting started page. This is what we were just talking about. We were just saying that LangChain here, another set of APIs. It has a lot of different functionality. We'll talk today a tiny bit, as much as we need to know to understand what we're doing today, about the LangChain expression language. It basically is about how we can compose these different elements of LLMs to form a chain, which is doing the thing that we want. Within the LangChain expression language, we have these different components. We have a model IO, which essentially comprises what we did on Monday. So essentially what we had was some text that we wanted to send to the model. We formatted it ourselves. And then when we sent that to the model sent back a response, and we ourselves had to do like the response stat, what is it? Content choices, something. Don't even remember. And that's why we have output parsers. Output parsers take whatever response that you get, and it returns whatever format that you want. Usually for us, that's going to be a string. We're talking about RAG today. So what is RAG other than retrieval-based generation? What? So what we can see here is we have lots of functionality then relating to retrieval. And we can also see, we'll see this on Friday. Friday, we'll look at the agent tooling, which will allow us to make agents. Also, you see these other things. We'll talk about these more. Today, we'll talk a little bit about Langsmith, and what they call it is observability. When you have these chains, like sometimes it can be super hard to know like what exactly is happening in the chain. And so we'll talk about how we can see that. So also on Monday, someone asked, delicious question. That question was, hey, like, thank you for showing me how to copy and paste. Like, I low-key already knew how to do that. How do I actually build how do I build these systems from the ground up if I don't want to copy paste? Well, the answer there is that you kind of will always start with copying and pasting. And that is the foundation of a developer-friendly, documentation. So here you can see that this is not this is not the API. If a developer or if a system only gives you the API, like you have to figure out how to assemble all those pieces together to make it work. What you like to come to instead is a page that looks like this. You can see that it has different types of information on it. So what you normally do when you're getting started with the API is you go to the get started page, delightful, and then you go to the quick start and you walk through the basic functionality that they want you to know about. And so this is a lot of copying and pasting, but it's a lot of narrated copying and pasting so you understand what the whole point of this whole endeavor is. After that, you tend to read through some of their examples. They try to give you the highlights first. Often you explore lots of other things before you get to the API. So for example, today, we will be getting heavy duty into these different components that we saw with LangChain. We'll be talking about all these different things. Then they have these different integrations we'll also be talking about. They have guides, the API reference. Now you see that this is a horse of a different color. It looks completely different. Like visually, we're like, oh my gosh, what is this? And that is because this is the technical documentation. So yes, you normally do start out with some lovely copy and pasting just to understand how it works. But then once you understand the particular elements of what you're looking at, you come to the API to figure out how exactly you can use it more. All right, then let's go try. Okay, so what we said is that we are looking at these individual elements. Before, we're just going to have a little just primer, a little reminder on F strings. So F strings are formatted strings. In Python, Basically what they do is they let us, they give us more flexibility when we're trying to format a string. So what does that mean? We might try to print something like this. We pass in like the very specific thing that we want to print. Whenever we're programming though, what we might want to do is to actually have that string be a variable instead. So maybe if there's an output of some function, it can output whatever, which will be stored as prompt string, and we'll always print that prompt string. We can augment this particular printing by adding this F string. And so, I mean, that's why it's called F strings, that's F in front. And whenever you see F strings, what you see is that there are these curly braces, and then there is the variable name that is within it. So how does that work? We're going to run Shift Enter to execute this cell. Basically, what happens is that we see that in this last line, we have our behavior of our formatted string, where it kind of behaves like the second line, where we're printing this as string and then the prompt string. Here we have more formatting through these curly braces, which puts this variable prompt string into the place where we wanted the output to be placed. So here we have this variable name prompt string, and when we print it, it substitutes this value into this value. So what we can think about is maybe using prompt or using these F strings as something closer to templates. Okay, what is a template? So that is a further augmentation of this prompt string that we've seen here, and this F string where we have two sets of curly braces where the inner one is going to be reflecting a variable to be replaced whenever we format the prompt string. So here, and we would refer to this with these double curly braces as a prompt or as a template. So here we run this. We see the output of this template. So raw, this is what it looks like. It's still a string. But what we can do is format that string so that whenever we want to actually pass in a variable here, we can pass in that variable using the name of this field that we want to modify. So what we're going to do is we take this prompt string template, we use the format method on it, and then we say, okay, where we had topic there, actually, I want that to be cats. So then if we run that, we see that this has been filled in. And so why we like this is because you can imagine that there are cases in which you want actually a message that you send to your LLM to be the exact same, except for one little piece. So this is a great example where, let's say you have a GPT, which is always telling stories. And in your user interface, what you have is a drop down with different topics, or you would allow the user to type in a topic. The user then is not going to be typing in a whole message. They're just going to be typing in a topic or selecting a topic. And then all your system, your program needs to do is just fill in the blank. And so here we can see the effect of that. All it does is fill in the blank, knowing what the name of the blank is, and it reformats this string. And yes, this method is built in. So LangChain prompt templates are basically like this, but they have more functionality related to that thing that we were talking about, the LangChain expression language. And it's meant to fit into the system that they've created for creating these LLM chains. So we're going to go ahead and run this. Again, we might have downloaded things from Amazon, but we got to take them out of the box whenever we want to use them. This is taking them out of the box and using them in order for our system. So you can see that we're using prompts, these different types of prompts that are available, prompt types, message types, and then this output parser, which is going to help us to actually format the output without us really even having to do anything. All right, we can run this one. This is just a system message to help us have a little bit like shorter results, because sometimes we know that these models can be a little bit more verbose than what we would actually like. So let's start our first endeavor with a prompt template. Actually, maybe we'll just click on this to make sure that we know something about it. So if you want to learn more about the different kinds of templates in depth, you can click on that link, and you probably will for the homework. Again, it's really about, it's like a augmentation of an F-string template that has more functionality outside of just the formatting. And it fits in very specifically with our LangChain expression language. Okay, so let's create our first prompt template. And what we're going to do is we're going to use prompt template from LangChain, and we're going to create this from the template. What that template is going to be is the same thing that we saw before. Tell me a story about topic. And essentially what we would see there is LangChain is going to, in creating the prompt template, it's going to make it so that this is essentially something, this topic thing is something that we can format. So if we run this dot format, and again, we're using a prompt template. After we run this line, we're not going to run it individually, we run the whole cell. But after we run this line, what we'll have is a prompt template, and it'll be stored into LC prompt. We're going to use that same method that we had before, format, to format that so we can pass in or substitute what we want for topic. So now we're substituting in for this. We can run this. So shift enter. So we're setting topic, this thing here, to be cat. You can see we have something more than the string that we had before. I'm not going to scroll up, but before we just had output of strings. Now what we have is this output of a LangChain type, which is a prompt template. And when you want to learn more about prompt templates very technically, this is the moment where you go to the API, have it copied and pasted from the guide. So now you see something interesting. You see that they have noted what this variable should be. And you have also seen that we have this. Oops. And also, I'm going to comment this one out real quick because actually we didn't see the output just then. So I commented that one out, and now we're going to do shift enter. This is the output of this formatting. So we have the regular string, tell me a story about a cat. This LC prompt thing that we just saw, this is the content of LC prompt. It tells us about the kind of object that it is. So again, we can go back to the API, but we have something special with prompt templates because they are part again of this LangChain expression language. And what does that mean? The LangChain expression language has some very particular functionality associated with any of its elements. And one of these things is the ability to call the invoke method on it. So for each of the LangChain expression language objects, the invoke parameter causes that object to run. So what does that mean? It made no sense. Let's try again. So we're going to call invoke. We're going to pass in a dictionary where we want topic to be substituted as cat. This is just a different way of looking at it, or a different way of writing it. And so what we see there is when we invoke it, it executes this LC prompt and it returns something expected. So I'm going to open this up right quick. All right, great. So again, what you just saw me do is I just opened up the table of contents. I wanted to make sure I didn't skip talking about LangChain expression language. We will get to that. If you ever get kind of lost in the sauce, don't know what we're doing, don't know where we're going, go ahead and open up that outline. I love the outline. It's like my favorite thing. And it tells you all about what we're doing in the individual components. Okay, so this is one kind of template that we can use. This is just a standard string prompt template. The next one that we can use is the one that is more appropriate potentially for chat models. This is a chat prompt template. And so it has additional functionality on top of just prompt template, and it's about chatting. So here we're going to do essentially the same thing that we just did above. making a prompt template from this string. It's going to be stored into this variable, and then we're going to invoke it. So we're going to cause it to run with a particular set of expected inputs, and it'll have an expected output. So let's run this one. You can see that it is a chat prompt value. But something interesting, okay, is that you see that we have these messages because it's a chat prompt template. So you remember how we talked about at the very beginning of the day, how we had these different kinds of messages. Here you see the implications of that in a generalized system that has lots of models available. This chat prompt value, this chat prompt template, all of these have these different, the same sorts of messages, a human message or a user message, a system message, an AI message, an assistant message. All of them are standard ways that we do chatting. So this time what we're going to use is we're going to use a different functionality, and it's going to be called from messages. So just then we had from template. Now we're going to have from messages. And what we're going to do is we're going to input the messages. So because this is not OpenAI, the appearance of the messages will look different, but you will see something interesting in that what we need to pass in is still a list. Oh, that auto-completed in a way I didn't want to. So we need to pass in a list. And what we are trying to do is to compose a conversation or the beginning of a conversation like we had on Monday. So what we're going to pass in is a system message. For example, we're going to use that brief system message that we saw before. We put a comma because we're going to add another part of the list. Thank you, Colab, for popping up all of these delightful things, even though they're a little bit in the way. So we also have a second message. As you recall, this is the same thing that we had before. It just looks a little different. So the role here is the system. The role here is the user. The content here is the brief system message. The content here will be tell me a story about topic. And so now we have a chat-based implementation, a back and forth sort of implementation that is reflecting the chat nature of, chat LLMs. So this is a way that we can use this chat prompt template. And you can see here, we're going to use the same invocation, passing in cats to substitute for topic. And we can run this. And what we see is, you remember from Monday, again, we had the system message. Now you see the system message here. It's called something a little bit different in LangChain, very general. Now it's called a human message. Before we had role user. So again, we might have copied and pasted this, even though we didn't, from the guide. And so now if we wanted to do more things, we would know that if we need to do something specific with the chat prompt value, we would go to the API and look that one up to figure out the other things that we can do. If we wanted to know more about what we can do with the system message or a human message or what other kind of messages there are, that's when we would go to the API reference and look that up. All right, Shane.
Yeah, can you just step back and help me understand the difference between format and invoke? Are they just different syntax? Is there a value of using invoke, or is that just a standard way of doing it in LangChain?
I love that question. It's a great question. So format is like a very Python, like I've been programming Python for 100 years. What I do is I format a string. So that is a very familiar thing, but I'm so glad you asked that because invoke has a very specific meaning within LangChain. And so to answer that question, we're going to come over to LangChain expression language. So I'm going to go ahead and click this one. And here we see LangChain expression language. So the thing about LangChain is they've tried to make it very, very simple, or maybe not simple, but straightforward to create these LLM chains or just chains of functionality, meaning that if you want to implement like retrieval, you don't have to write that much to make it happen. If you want to do parallel branching and retrieval, if you want to create an agent, it all has a very standard sort of interface. So chat prompt template and prompt template, these are two foundational elements of LangChain expression language. And because of that, they have some particular behavior. they have these particular behaviors as part as the expression language. So we are able to stream, which we won't talk about, and we can do it asynchronously. We can, I'm not sure if you've used the LLM before and it's been like, oh, I can't do this. I've timed out, like I ran into an error that, I mean, don't know why, but I just didn't work. In that case, in our system, we can build in this ability to retry that particular piece of functionality. We can also see what has an input or output. We can also do this tracing, which we'll see today. The most foundational thing that you will see. So here we are with getting started. So again, if this was you by yourself, you would go to get started and you would do all these things. Back to the invoke thing. So all of the elements of the LangChain expression language, they implement this particular protocol called runnable. And so for models, for retrievers, for parsers, for templates, you will always be able to call these things upon it. So whenever you call invoke, it basically means that I am like executing something in particular. And because of the way that they have implemented this runnable interface, you can always know what to expect. And because you can know what to expect, you will know how to chain it to the next piece in your chain. So here also it has all these other types of things that you could do. And the interface for all of these different things. So for your prompt, for your chat model, for your LLM, for all of these retrieval, it's always going to look about the same. The difference is what the component is. So for here, we see that the prompt, when we called invoke, we passed in a dictionary, and we saw what the output was some sort of value. When we call this on a chat model, OpenAI chat model, whatever, when we call invoke, what it will expect will be something like this. So either a single string, chat messages, prompt, blah, blah, and it will output this. When we have an LLM, it will expect this and output this. And again, because of that, because of the way that they've implemented this runnable interface, which we use through invoke, we know exactly how to stack the chain so that we can put elements together. So in totality, the story is formatting will do normal string stuff to, change the behavior or, substitute things in. Invoke is related to the LangChain expression language, kind of like what you just said. All right, awesome. What a good question. Such a good question. All right, so let's explore that even more. Okay, so what we're going to do is now we're going to go into the other elements of the LangChain expression language. We're not going to go way deep into it because, again, it literally says LangChain expression language. And although parts of it do generalize to other like different approaches like Llama Index, like the syntax of the language, we're not going to kind of emphasize here. So if the syntax is like looking crazy to you and you're like, oh, that doesn't make any kind of sense, don't worry about it. Like the point is not really to understand that in depth today. All right, so if you want to learn more about basic model chains, so it's somewhere in this quick reference, but here is some more details. We want to talk about the prompt model chain. So essentially what that is when we have a prompt, we want to put it into a model, and then we just want that response. So basically a generalization of what we did on Monday. So what we are going to do though, is we're going to use the chat OpenAI model. And what that is essentially a wrapper. So when you think about a wrapper, like if you ever have like a piece of candy, like it comes in a wrapper, it's just some functionality that houses the thing that you actually have been using inside it, but it has some additional functionality outside of it. So like a wrapper on a piece of candy also protects that piece of candy. It looks pretty, it attracts the user. So it has this additional functionality, but the main functionality is always the piece of candy. So here, our functional piece of candy is the chat client, OpenAI. So again, this is just a wrapper on the thing that we did on Monday. So here what we're going to do is we're going to use our standard prompt template. We're going to create a model to talk to, and we're again using chat OpenAI. So we're going to define our prompt just like we did on Monday as a string. We're going to define, we're going to specify the model, which we also did on Monday. And to put those two things together, to create this chain of functionality, we are going to decide that the prompt So once we invoke the prompt, it'll have an output. We're going to pipe that into the model. And recall that we learned that when we invoke something on a prompt, it has an expected output. Because of lang chain expression language, that output will be expected by this model input. So let's run this to create our chain. If we want to, maybe we can just like look at it, see what it looks like. I just created another cell by going here and clicking code. And then I just wrote chain here. And here you can see that chain. It's going to be the chat prompt template that we just talked about going into a chat model. So we can also invoke any particular part of this chain. So here, let's start by invoking the prompt to see what the output will be. Our input is going to be cats. Here we see that we have a different, variable name. So we use this variable name here and we substitute cats for it. We see that the output is this chat prompt value. And now if we want to use the entire chain, so we want to put this prompt into the model and get the output, we can just do chain.invoke. And what are we passing in? Whatever the input needs. So right now that input, what is needed is foo. So foo, passing in our dictionary, and we want cats. We want to joke about cats. We're going to store that into a variable called res. And then we are going to print res. So let's run that, shift enter. So delightfully now you see the response from our chain, right? So we already saw that when we had this input into the prompt, we got this message out. We know that this message then goes into the model. The model calls to the OpenAI API, which then returns us a string or returns us a response. So here's the content of that response that we see here. So interestingly enough, I want you to ponder that. This essentially is the entirety of what we had to write for Monday. Is that not interesting? That's why we like these, oops, I am missing some chat messages. I'm so sorry. So that is why we like some of these functionality that are associated with these larger wrapping platforms like LangChain. Because one, what they're going to do is they're going to abstract what it means to be any particular model and provide standardized ways of interacting with any model. But then also they're usually going to simplify things for us. Do know that this simplification is great. This generalization is great, but whenever you get like way down deep into this, the nitty-gritty of what you need to do, you'll probably have to come back out and start writing your own code to make that happen. But this is great for if you need to learn literally what to do. So now that we've understood how this chain is basically working, we can look at it a little bit more. So here we have some functionality provided through LangChain to help us see what happened. So again, we had the prompt input, foo, and we passed in cats. That went into the prompt template. The output of that went into chat OpenAI. And then the output of that is this OpenAI output. And so someone was asking, well, I guess I'll keep going and I'll explain it in a second, but someone was asking, so I'm gonna scroll all the way down. Someone was asking about this pipe thing. So I want you to think real quick about whenever you're adding things together in Python. We are used to looking at like functions and methods like this, but this thing right here is like an operator that has functionality associated with it. Not only is it add these numbers together, in some context, it's concatenate these two things together. And so we can define these pipes, these bars to have specific functionality. And that's what we've done here in LangChain. So basically what that means is you should treat this as like this mental like pipe. What flows out of prompt flows into model. What flows out of model flows into string input parser. What a good question. Someone asked whether this LangChain implementation here that we're seeing is it only possible in Python? It is possible in Python. It appears to also be possible in other languages. I think that if we look at the quick start, maybe somewhere in here, we see that there are some other languages that are available. In some instances, it will only be Python. Langsmith, when you have to go to that documentation as it's like being developed. Good question. Let me pause here right quick and answer a few questions, just making sure. Are the variables prompt, model, and chain standard for us to be able to invoke these? That's a really interesting question. So, So the chat prompt template, standard to be invoked. Chat OpenAI, standard to be invoked. And so these types are definitely standard to be invoked. And because they have saved them, we have saved them into these variable names, these are standards to be invoked. And if I may quickly go back to LangChain expression language. There is a list somewhere. I never remember where things are. There is a list somewhere in here about the distinct types of inputs and outputs that you can expect. I think we literally just saw it, but now, of course, I can't find it. You can never find it twice. There's this one. So you see that we had prompt, chat model. There will also see output parser and emitter and retrieval. So these are those components. And if you want to look more about any of those individual components, what we're talking about now is model IO. So we have prompts, chat models, and LLMs. These are the runnable expression language compatible things where we can call invoke. And then we also have this additional functionality as well. I see that someone is asking a really great question about RAG. We will come back to RAG. Will we use the chain.invoke? So will we use chain.python? So when we use chain.invoke, Python LangChain knows what it is doing. Yes. And that is so the question is, whenever you use chain.invoke, where is that executing essentially? So yes, Python and LangChain know what it's doing. If you want to learn more about this, again, someone was asking about copying and pasting and just hating that. Totally okay. I've been there myself. This is when you go to the API reference. And when you want to know more about what exactly is going on, because this is open source, is very exciting, you can look at where the functionality occurs. So here, I'll just tell you where runnables are. There is one here, but that's not the one that you want. What you'll do is you'll go to core, you'll go to runnables, and here you see all of the possible runnables. So here's this one, because this is the interface that is implemented by all of these models. And so here you see all the base functionality. If you literally wanted to know exactly how it works, you could also go to source and literally there's the Python. So this is another reason why I like LangChain and open source platforms. If you're really trying to implement something, but it's not quite right, what you can do is go to the source, figure out how it's implemented, and then fix it. Those are really exciting and delightful questions. Okay, so before we take a brief little break, let us go through the next section just a little bit. Actually, this is perfect timing. It's perfect timing. Okay, so now let's talk about a different kind of prompt. The same exact thing, but with a different input. So before we had this moment where we're oh, we're going to use this template, we're going to let the user fill in the blank. Here is how you can implement this if you want the user to be able to like full chat GPT it. So whatever the totality it is that they write, it will all be here. All it is a string of text. The text is completely replaced by whatever the user inputs. Here, what you can see is we've created this prompt. So what we're going to do, the entirety of our chain is going to be using the prompt. The user will end up passing this in. Oops, sorry, I don't know why this is here. The user will pass this in, this text in. Then from the prompt, it will create the particular output to pass into the model. It will pipe it into the model. The model will be invoked so that it passes it to OpenAI, and OpenAI returns the response through our chat OpenAI functionality. That will be then passed to this thing called a string output parser. So let's run this. We're going to shift enter. So this creates the chain. Now we invoke the chain by passing in text, filling this in with the dictionary value. Let's run this, shift enter. So now it essentially, again, we passed in this. It went into the prompt template here. The prompt template outputted something and it passed it right on into, or it piped it into the model. The model executed how it did, which was basically to call the completions API and return the answer. Then we have the string output parser. If you remember from above, the output was actually, before we had this parser, actually, I am just going to scroll back. The output was all of this. So that's a lot to look at. That is why we add the output parser, because now this thing, that whole giant thing, goes into the output parser. It parses it into a string. So now all we have here is just that string of the answer. So it is pretty delightful. So generally, when you look at LangChain's output documentation about these string output parsers, or about output parsers in general, which what it's going to say is, oh, like we don't really do output parsers anymore. It does string output parsers, but otherwise, if you want more structured output, you use something called function calling, which we will talk about on Friday. So before we get, okay, we'll do this last section before we take a break. So people have been asking about like what's going on? Like, how does it, like, why is it working like this? How is it working? How does it work under the covers? How do I see these inputs? Like, what's going on? Well, LangChain does provide some functionality to be able to help with this, to be able to inspect the behavior of our executing chain, because it's sometimes just not helpful to see the output. You need to see what happened before. So from this globals, like module, we have the set debug and set verbose. So we're going to run this one to add those into our computing environment. And then we're going to run this one. I think there currently still is an error with set verbose. It should have different behavior than set debug, which it does not appear to do unless I just haven't looked like deeply enough. But basically what that's going to do is it's going to tell us all the intermediate steps, what's going in, what's coming out. So this is the same exact thing that we just had before. And so we're defining that as chain. We're going to invoke that chain on this input. You can see here that this actually isn't a dictionary. And if you invoke it like this, it's just going to call the input and substitute whatever is there. So here we're going to run this. And now you see the full behavior. So you can see when we're beginning the chain, what happens. Our input, it's going to call this input because we haven't specified the name as a dictionary. It goes into this. So this is the full chain. So this is the entry into the full chain. So this whole thing. This is the first subchain where, so this is the start and end of the first subchain, which is when we enter this and use the prompt template. So here we have this input of the prompt template. On the output, we have the formatted prompt template. So exciting. Now this is the LLM part that it's going to be talking about. So we saw that the output of prompt is the input of model. So here we see the start of this chain. The input of this section is this formatted thing. The output of this section is exactly what you would expect. This looks a lot like that output that we just got from OpenAI's chat completions, right? So you remember like completions tokens, fingerprint, ID, I mean, all that great stuff, number of tokens. So that's the output from ChatGPT. Exciting. Then it talks about that next chain, which is the string output parser. The input was the input here. You can see the output at the chain end is going to be this output. You can see it changed all these things here into just this one output, such that the output of the entire chain, which is to which this refers, is this. And then we printed it out. So this is a lot to look at, but it tells you precisely how things are occurring. Excellent question. Someone asked what the set debug true and set verbose true do. So debug usually refers to the ability to see like the intermediate like steps of something, or to be able to inspect the innards of something. So that is what this does. It allows you to see the intermediate steps. Verbose is meant to actually simplify this whole thing, but I don't really know that it is. But maybe one day it will. So essentially, I think what's executing is set debug. And so here we're able to see the intermediate steps. We set that to be true. And in a second, we're actually going to set that to be false. But not this second, because we are going to go into a break. I'm going to hide this output because it's a little too long for me. So this is how we can debug directly with LangChain. We could also debug with Langsmith, okay? With Langsmith, though, you need an API key. So during the break, maybe we'll have an 8-minute break, which will also allow you to have a user interface and additional functionality in which you can inspect the behavior of the system. So during the break, we'll come back at like 10:10. So you'll have 8 minutes there. But during the break, if you wouldn't mind, maybe use the first 3 minutes to create a user account on Langsmith. After you create that user account, you'll be able to create your API key. If you remember, after you create your API key, you want to come back over here, call it exactly LangChain API key, and then paste in the value. All right, so let's take a little brief break, try to get that done within that time. We'll come back at 10:10, and then try to have your Langsmith LangChain key created. If you don't want to do that, don't worry. Don't worry even a little bit. This code will work perfectly without that, but I'll show you how it works. So coming back at 10:10. All right, and we are back. Let me go ahead and reopen my participants pane and my chat so I can see any conversation easily. All right, exciting. All right, so if you created an LangChain / LangSmith OpenAI AI key, API key, breaks too much. All right, if you created that key, you'll be able to uncomment some of these cells and keep running, some of these lines and keep running. But otherwise, if you did not create a key, if you did not put a key over here, then do not uncomment these lines. So here, we're going to go ahead and run this. We're going to set debug false because we'll see all this input every single time, which will be a little bit of a visual challenge there. And then again, this setting right here, it sets an environment variable where we will be able to trace all of the chain calls which occur. So we need to set this one. If you have an API key for LangChain, so not OpenAI, this is a different API. It has different expectations. It has different wants and needs, and it wants to bill you, not through OpenAI. You're going to want to set your LangChain API key over here. You're going to want it to have this exact syntax because this is what we're going to be looking at here. And then we're going to uncomment this so that actually our LangChain tracing v2 is going to be true. So if you have an API key for LangChain, uncomment this cell and uncomment this cell. If you do not have a LangChain API key, leave it commented. So I have one. So I'm going to uncomment, and I'm also going to grant notebook access so it doesn't ask me any questions. Then we're going to go ahead and run this. So what that did, one more time, is it set the tracing to be true if you have a LangChain API key and uncommented this. And then now that LangChain API key is in your computing environment so that the system can read it easily. The second thing we did was we created a project for specifically today. And so all of our traces will be stored under this particular project. So now this is going to help us to inspect our chain after we run it. So here you see the exact chain that we had before, except now we need to do just one more little thing, which is going to help us to be able to identify what exactly is the run that we're looking at. We're going to use this with_config and its functionality that's associated with LangChain runnables, specifically, the LangChain runnables. What we're going to do is we're going to set a run name. Run name, and we'll just set that to be basic LLM chain. And what that's going to do is it's going to make it easier for us to identify what we're going to identify this easier using LangSmith. So what we're going to do is we're going to run this. So this will create the chain. We're going to invoke that chain, going through all of these different steps. We're going to get a response and we're going to print it. So again, because we have our string output parser, we have this nice output here. And now if we want to understand another way, in addition to the LangChain way, is we can look on LangSmith and we can click here. And so again, if you have an API key and you have a account, which you have to have, then you'll be able to see this. So here we're going to LangSmith. So we're not going to go into too much detail about LangSmith, other than the fact that it is delightful. It is like very much a work in progress. They have lots of additional functionality to add, but it is a great way to look at what is going on in your chains. So you can see your project here. This is going to track all of the runs that we do in the class today. So if we click on that, we can see this run that just occurred. So here you see the run name that we had. You see the overall input and you see the overall output. You see these other nice things though. Okay, right? Those are interesting. You also see some things about money over here, and it allows us to really be able to inspect by filtering different components. So here's the run name, there's different run types, and so forth. So now if we click on this, we can see more details about what occurred. So this again is enabling us to inspect the individual steps of the chain. This particular block here is telling us the entire summary. So what we had as input was this, as we expect. What we had as output is what we just saw printed out. But what we also know are there are a lot of steps that occurred in the meantime. So first we had to put things in the chat prompt template. So the input for this one was this. And then the output of that was something similar to this. Then we know that that was sent in or piped into our next step, which would have been going into chat OpenAI. It received this input or similar. And then this output, this is the output that it prints. Now, something to know about Langsmith, it is a work in progress, and there are additional things that we would need to add if we wanted to see very specifically the output of the chat OpenAI. But this is the output that is available through LangChain, and we could do different things to get the full true output because it's not exactly this. Then we know that this output is going to go into our string output parser, and then we'll see the output here. So again, generally, when you're looking at chat OpenAI right now, it's not going to reflect the exact output that you get, like when we were looking at debug. But I'm sure they'll have updates which will make that possible. There are also different implementations that can also help us to make that possible. All right, coming on back. So that's delightful. So now, Amir?
Just a very quick question. So when I'm creating the API key, it's asking the description for it. Is that where I need to make sure that the name is met? No? So,
That's a really good question. I'm glad you asked it. That's just something in your brain to help you remember like what it is. All right, so I'm going to step on the gas just a little bit and depend on my colleagues to help answer more questions in the chat. Want to make sure that we get through full RAG. So first, we're going to talk about adding memory, though. As we answered in the beginning of this workshop, the history has to be managed somehow, and now we can talk about this. So let's run this one. There's a good question in the chat that I'll get to in just a second. It's about the advantage of Langsmith versus debug. Such a good question. I will answer that in just a second. Actually, with this example. All right, so we brought in these things that we need to have in our environment to use chat history. You can see that there's something called literally chat message history because we have to implement that. Here you see our usage of the chat prompt template from before, right? So now we're creating these sets of messages. So here you see a list of messages, just like we had before when we were experimenting. We had before the system message, before we also had the user message. Here, we call that the human message. And for that particular value or the content of that, we're just going to use a straight F string, and we're going to let the user have full control of what they input. However, we have this additional piece, right? Because a conversation has more than one turn. At the very beginning of the conversation, like we don't know how many turns that'll be. And so what LangChain provides to us, and also other platforms, is this notion of a messages placeholder. And so basically we can update that thing, we can do whatever we need to do to the placeholder, and it will be substituted in here whenever we need to add in that information. So what we're gonna reference it with is something called chat history. So this looks a lot like how we reference things for our prompt templates. Whenever we're trying to fill this thing in here, we will use the variable or the field name chat history. So now that we've defined our model, we've defined our prompts, we can define a chain. So we know that the inputs will be the chat history and this user message. And so what we're going to do is make a chain where we'll have the prompt going into the model, which is going into the string output parser. But again, we see that we'll have more than one input that we will specify. So let's go ahead and run this one. So now we're going to explore like what this sort of looks like. So again, we need to specify exactly what it is that we need to pass in. So here is so we're going to pretend that we are already in the midst of conversation. We're going to pretend that we've already said to ChatGPT or the OpenAI API, we're going to pretend that we've already said, tell me a joke about cats. And we're going to pretend that the AI has already responded that cats jump on beds. And then our next message that we're going to substitute to end at the very end of the conversation is what was funny about that joke. Okay, so we're pretending that we're like literally in the midst of conversation and now we're about to say something else. The way that we're going to make that happen is we're going to use like invoke, of course. So with invoke, what we're going to do is we're going to use this reference to chat history, this one. We're going to pass in this set of messages that we've already had. That is the chat history. And then we're going to make our new statement, which is going to be most recent user message here, which will be at the end of the conversation history. And that's going to use the new user message, which is this. So let's go ahead and run that. You can see here that now it is responded. It says it plays on the common behavior of cats jumping on beds. So this is 3.5 turbo. Maybe if we were using 4, it would have said, actually, that's not a funny joke. So we know that this is working. It's making sense. And so now we're going to add this very foundational kind of chat history. So essentially what we can think about, okay, in our brains is when we go to ChatGPT, the left sidebar, it actually has all of the conversations that we've saved, right? We can think of those as every individual one being like a session or like a thread. And somehow you have to store these, right? So I don't know if you tried this before, but you may have had a conversation way back in the day and you're like, actually, let me go ahead and continue that conversation. What is probably associated with it is a thread ID that will allow you to load the entire conversation history into the context and then start adding messages to that context. And so here we're going to simulate this, a very straightforward way of doing it, which will only use like this Python memory that we have here. So here what we're going to do is we're going to like mentally be creating this sidebar. We're going to pretend that this is the first time we've ever seen our personal LangChain ChatGPT before, and the sidebar is clear. So that's what this open dictionary is. And what we're going to start adding are these session histories. So what this session history is again, when you go and click in any one of those threads, it loads the entire chat history. So that's what this does. It looks kind of crazy, but basically what happens is if you run get session history, you'll pass in the ID associated with any of those sidebar conversations. If you've never used ChatGPT before, you would never have one of those sidebar sessions. So we will create one. And then we're just going to return it. So it's going to have the entire message history. So here we can create a new type of chain, essentially. It's called a runnable with message history. And what we're going to pass in is the actual chain that we're trying to essentially like augment. We're going to pass in the functionality that is associated with getting the session history, because if we're trying to create something with memory, we have to get the memory from somewhere. And so that's going to be get session history. It's returning the entire chat conversation. And then we have to specify 2 parameters, one of which is like when we invoke this, what is the key that we're going to invoke with, and what is the history key that is associated with this. We're also going to add this with config because we have Langsmith, and we're going to call it the run name chat with message history. So this is a very foundational way of creating these different threads, and then the history is associated with the particular thread. So hard to explain, but let's see it in practice. So we're going to start by creating a new thread. So that's going to be our session ID called Convo1. So this is the first conversation we're ever having with our LangChain ChatGPT. We're going to have this be our first message. And so what we can do is just go ahead and add that in. So our first message that we're going to add, and I'll highlight that, make sure to keep this curly brace at the end, is user message 1. And then we use this syntax because this is, we're going to use this syntax. This is basically something in LangChain that reflects the fact that we can change this parameter as we're going along. And we're going to pass in the specific thread in ChatGPT that we're referencing. In this case, we don't have any. And so we're going to use, oops, actually, I'm going to use, that's not even a real thing, session ID 1. So this is just the ID that would be associated with any of the threads that we see in the sidebar of ChatGPT. So let's run this one. So one, you see this warning, blah, 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 long story. Root run, this is a message from Langsmith. It's basically saying, hey, like, it looks like you're trying to chat right now, but I am going to log this as individual invocations instead of individual invocations associated with an overall chat. That's basically what it's saying. So here we have invoked this chain with the message history available through session ID 1. We have sent our first message and it answered, here is a cat joke for you, blah, blah, blah. Why was the cat sitting on the computer? Because it wanted to keep an eye on the mouse. So now what we're going to do is we're going to add another message. What we are doing is we're keeping the chat history by referencing the same conversation. And you can see that here. Here's the session ID. This is the same session ID that we had before. But what we're going to do is add another message to our session ID. And we're going to say something like, I don't know, let's say, I don't get, oh, nope. So here is a particular likely a lovely thing about Python. It allows you to use curly double quotes or single quotes. We're going to use double quotes here because I'm about to have a single quote within it. I don't get it. Can you explain? So the interesting thing about this is if there is no message history, it should say something like explain what? Like, I don't know what you're talking about. But if there is message history, then it should explain the joke that it just told me, this cat joke that it told me. So let's run this one. So here we can see that there is some chat history because it says, hey, the cat is sitting on the computer, blah, 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 blah. So it's following up on this. So I could go into more detail about this, but we have 30 minutes for RAG, which is painful, but we're going to make it through. So we can quickly look at this on Langsmith. I'm just going to open it up again. This is a reason why we might like to use Langsmith, and it will have additional functionality, but there's even more functionality outside of this. But generally, we can see this first chat history or this chat with message history. And you can see here that the first thing it's going to try to do is actually insert the history. And that's that thing that we had when we were get session history. You see here that the chat history is literally nothing because there was no chat history on our first call of it. Here you can also see the actual chain that we use in addition to the insert history. In the second one, what we can see is something that's a little bit different. With insert history, there actually is history. So this is looking at the overall set of execution steps. One, we said this was the input. I don't get it. Can you explain? After it ran its insert history, what happened was we have this most recent user message, but we also have this chat history. And so you can visually see it in a formatted way. So here in this runnable, we can see that the whole input is this with the messages. And we can see in the total runnable chain, here is the input and here is the output, even though the history was loaded. One last quick thing, because someone was asking about Langsmith. I'm going to go to the documentation. Actually, the old documentation is better somehow. And I think I have this here. Sorry, I'm going to make it a little seasick. So, good. Yep, I still didn't do it. That's the same thing. So the thing about Langsmith, okay, then let me do this. Thing about Langsmith is that it is more than just the tracing. It has the full life cycle that you're able to access in this like API and in this system. So we just talked about like maybe if we're developing, how we can see the execution of the different chain elements. But also what we can do is create test data sets to make sure that when we update the model or make changes to model that it behaves differently, or it behaves the way that we want, or it behaves the same. We also have these different evaluation metrics that we can apply to our system. It also gives us the ability to integrate and see human feedback, like how that works within or how we can utilize that within our system. There's like automation that we can add. Like Langsmith it's nice for visual, like it allows us to see things visually. It also, as Jesse was saying, really, really nicely, it helps us to see something outside of what we're doing in Google Colab, because in Google, in an actual system, you wouldn't be on Google Colab, you would be on something like AWS, and then you wouldn't actually be seeing this like while you're running it. So it's like a more enterprise type solution than what we see with LangChain. All right, now RAG. Luckily, Jesse has given us a delightful introduction to this, so we won't spend too much time on the different components, but briefly, there are some different stages of RAG. The first stage you might think of is not even like part of the RAG execution. It's about preparing the inputs. As you recall, RAG allows you to separate your documents into individual chunks and then retrieve those chunks whenever you are ready to use them based on their relevance. The first thing that we do, though, is when we have lots and lots and lots of documents, we need to prepare them. Some platforms would reference this or call this data ingestion. So this is before the actual invocation of RAG. This is something that you would do beforehand. It could be months beforehand, weeks beforehand, whatever. So what we do is we choose an embedding model. We are able to load whatever the documents that we want, documents. Maybe I have, so as the director of the minor, maybe I have a whole website which has all this information on it with FAQs that I want to use as my vector store. So I can load those. Then we do the chunking where we're splitting these documents into one or more chunks using using something that splits. Then we go and we do the embeddings on all of these individual chunks. So these individual document chunks that you see here, they all have individual embeddings, one for each chunk, and then we want to put them into some sort of store. Something to keep in mind, like always remember this with your brain. Okay, maybe not, but usually whenever, I mean, it is the case, whenever you have a vector store, what you have is not just the embeddings, but the actual document chunks alongside it. So whenever you're searching through your vector store, you have a bunch of embeddings. Whenever you have an input query, you embed that first and search against these different embeddings to get the documents that you want returned. But what is returned are the documents, not these embeddings. So let's look at the significance of that. So let's say that we've already created our vector store and we're ready to use that within our RAG system. What happens is you might add in a query, you say, all right, well, what classes should I take to fulfill this minor? And so it'll go look at all of my chunk documents. It will look at the embeddings in those chunk documents. We will compare our query, which will also be first embedded using the same embedding function that we used here so that we get the embedding. We compare those embeddings against the embeddings that are in the vector store. We pick out these blue ones, which are relevant by some metric. We return those documents to the LLM, or you can think of that as a part of the prompt. But the question also goes directly into the prompt. And then all of that goes into the LLM to produce an answer. So we have a step before, which is creating the vector store. with some embedding model or LLM that of your choice. And then we have the actual use of that vector store and the embedding model. The way that they are used is the embedding model is always called to produce the embedding for your question. That embedding is compared against all of the documents or however many your vector store implements it to retrieve the important ones in blue. Those blue ones are added into the prompt as well as your question. Those go into the LLM in order to produce an answer. So again, this LLM is usually, it's going to be different usually than this LLM because this LLM is usually going to be an embedding model. So it's going to be two different things. All right, so now we're going to go through all of these steps somehow relatively quickly. And so the first step, again, is the preparation. Just point blank, it's the preparation. This is from LangChain. As you saw before, there is lots of documentation about these individual components. In fact, this comes right from LangChain. So what we can do is we can execute this. These are just like a few different, I don't know, resources of PDFs that we can load from the web. We have the first thing that we need to do is we need to do the loading and the splitting. So that's what we're going to look at now. There are so many different types of loaders and so many different types of splitters. Loaders and splitters influence what is in your vector store, and therefore that influences how your RAG model behaves. So for the loader, for now, what we're going to choose is a PDF loader, and it's going to be called, it is the Pi PDF loader, available through LangChain, and we're going to load document 3. This here is creating a text splitter. Text splitter is how we create chunks from our documents. There are lots of text splitters available, and for your homework, you're going to explore how that influences the chunking and the different types of text splitters. But for now, we're using this recursive character text splitter, which will essentially like split on these. It chooses how to split and then minimizes to make it fit into your parameters. We're going to choose that we want our chunks to have size 800, and then for each of our chunks, we're going to have some overlap of 250. And of course, we might not see the chunk overlap so much depending on how the recursive text splitter decides to split it. So we'll define that as our text splitter, and then we'll split this into chunks. So what we'll do is we'll use this loader, which is going to load our document, again, a PDF loader. We're going to do this operation called load and split. And then for the text splitter, we're going to be very specific about it, where we're going to pass in that text splitter that we just defined. And oops, I for sure did not execute this. You don't see any check next to it. Let me make those available in our system. And then now let's run this. So what this is going to do is it's going to essentially create a PDF loader from this. Then we're going to load the documents and split them. So that may the document that we're using, by the way, is going to be, I think it's a Declaration of Independence, I think. So let's print the length of those chunks. If we want to see any individual chunk, we can just reference it in the list. We can see that what it is this document format or document class. And when we read the page, if you go, you can actually, go click this. Oh, maybe I have to come up, control click. There we go. I don't know where to open to. This is the document. Usually what I do is I come back and compare to make sure things are making sense. So here is the first chunk. We know that we have 138 chunks of size 800, potentially with chunk overlap 250. And now we can print a few of these chunks and look at them. So we're printing the first 3. And then if we were to go and look at our page, we would see that this is the first 3. So now I am also going to show you an example of scraping like the web, like a page. This is the US Constitution. We're going to use some of the integrations available through LangChain. You see that this is a document loader from the LangChain community, and it's a web-based loader. That should tell you something about that. There are lots of different types of loaders. So we're going to run this one. We're going to do this one a little bit differently to show you some additional functionality. So this is the website that we're going to be scraping. You can visit it to go see. But we're going to use this web-based loader instead of that Pi PDF loader. We're going to load the Constitution website. And then we're going to add some other functionality through Beautiful Soup. So this is called a soup strainer. You would have to know more about Beautiful Soup. Please feel free to go and look at that. But essentially, we're only going to return a part of the page. That's going to be our web loader. And then we're actually going to do the loading. So again, we're loading this one a little bit differently because what we're going to do is we're not going to load and split. We're just going to load first. So we're going to load so we can actually look at the document. So this is loading our document. Let's print some of it. So this is the first. So it returns this as a list. So this is like the document. And then we need to reference this page content because whenever we load things, it's a document. So here you can see the document. We've only printed out some of it. So what we're going to do now is we're going to split. We're going to use the same character text splitter, but we're just going to split it slightly differently. And what we're going to do is we're going to add something called a start index, because that will allow us to know where in the document that it occurred. Parameter is called add start index, and we're going to set it to be equal to true, keeping in mind that this is something that we would have had to learn through looking at the API reference. So here we're creating our text splitter again, like we did before, and we're going to directly use this website splitter to split this document that we loaded, called web document, and it's going to split it into chunks. And then we're going to examine that it has chunks. All right, it's split it at least into something, 210 chunks. Let's look at a few. And we see here the first 3. Again, keeping in mind that this is a document type, it's not a string. So if you ever want to get the content of any, like the string content of any individual document chunk, then you would need to use this .page content. And here you also see that we have added the start index where this occurs in the document, where this occurs in the document, where this occurs in the document. So if you ever need to make references to it in your code, then that's how you can access it. You also see that there is metadata associated with this, which is really nice. So we have the source, which is this actual link in the start index. You can also add additional metadata, which is really, really great if you ever have a more complex system, and it's also great for agents. So you can filter on metadata first, then do the retrieval. Like there's lots of things that you can do based on the metadata that you add. So we're going to run this one more time, showing that we can do this a little bit differently. Like we did before, we can use load and split. We're also going to use a different website. We're going to use Wikipedia. We are showing that we can extract different portions using soup strainer. And then otherwise, we're going to use this one going forward. So we're going to load and split at the same time, making sure to keep our start index. And we're going to look at those web chunks. Delightful. So what we're loading is the Wikipedia page on Star Wars: A New Hope. Maybe for homework, I can assign you to watch that before you come back, because I really love the Star Wars series, particularly the last 4. That's neither here nor there. And so all the things that we'll do after that will be based on this, but you can also feel free to add your own link there. Also, this is pretty short, so it's made to kind of save you some funds there. All right, so we've loaded and splitted our documents. Now it's time to create the vector store. There are tons and tons of vector stores. We could talk about vector stores forever, but it appears to be very short here. The main point is that your vector store is going to influence the kind of similarity scores that you can do. It influences the way that your documents are stored and the speed of that retrieval. So in your homework, you will actually explore that a little bit more. Right now, we're going to use the Chroma vector store because it is something that we can do in memory pretty easily. So we're going to use Chroma, and then we're going to create our vector store from documents. And for that autocomplete, I just click tab. And the documents are going to be the web chunks that we just created. With our vector store, because you remember what we said was that one, upon a new query, it needs to be able to create new embeddings. And also because it needs to create the embeddings for these documents, we are going to pass in how it's going to make those embeddings. And we're going to use functionality from LangChain called the OpenAI embeddings. And this is going to be calling their vector model or their embedding model to create the embeddings. So here, after we run this, Shift Enter, it is now creating embeddings for those web chunks, and that is stored in something called DB. Now we can actually use that. So let's say that we have a query, when was A New Hope released? We can look for relevant documents. We're going to call this relevant docs. Yes, this is going to create embeddings on our Colab instance locally and not actually in memory as well, and not on OpenAI systems. So now we're going to use that database to do a similarity search with the query.
And Char, I just wanted to clarify a little bit further. When you say that it's not an OpenAI system, do you mean that OpenAI is not seeing that data whatsoever, or through the embeddings, are we still kind of having data leakage?
This is a delightful question, and I'm glad that you're making that distinction. So this is very much using OpenAI's API. So the data is 100% going to OpenAI, being processed on their system, and then coming back. The storage is not on their system. Thank you for making that clarification and that distinction. Very important. Okay, so now we're going to do our similarity search to find, and what's going to happen is the database that we created is going to create an embedding out of this query. From that query, it's going to match it, like try to find the closest matches to what's in the database. So here are the results that are returned. This is pretty fair. The movie was released. When was A New Hope released? This is pretty fair. Released in 1977. Looking pretty solid. This one also, release dates, I mean, looking pretty solid. We can also get the similarity score as well. If we use similarity, I'm going to actually just scroll down, similarity search with score. I'm just click the down arrow. We'll do that against the query and we'll see what it returns. So right here, you see the same results because we're using the same query. Again, the database is creating the embeddings out of the query and searching what's already in the database. What you can see here is in addition to the result, we also get a number back. And this is the cosine distance, where the lower, the better. So this is the best match. We can also use a more normalized score. If we do DB, we're going to use something called the relevance score, similarity search with the relevance scores. We're going to pass in, again, the query. And what these are normalized scores, where instead what we have is the higher the better, and it's in the range of 0 and 1. So you can use these values to help you in terms of creating a threshold where you no longer want to include those in the results. So let's say that maybe our threshold was 0.79, then we would only return this one and above. So now we can create a retriever from this. So a retriever is, again, very similar to what we just saw. It's just that it has additional functionality associated with it, and there are other things that we can do with retrievers through using lane chain expression language. So the way that we're going to create this retriever is super straightforward. DB as, did I say receive? Am I saying receiver? As retriever. We do have the ability to pass in some other values, but we won't do that now. But again, this is pulling from the API to help you see the kinds of things that are possible. So let's go ahead and run that one. And we see how the retriever behaves. It's doing essentially the same thing, but we can use it. We see that it has this invoke functionality, meaning that we can use it alongside our chain. So now let's do that. Moving right along in these last lovely 10 minutes. you can see here that I'm actually going to switch to a different kind of embeddings, maybe to save you a little $1 or $2. And we're also going to use a different kind of vector store. The reason, again, that sometimes we like these platforms is that they present like this kind of uniform interface that allows us to switch things in and out pretty easily. So I'm going to go ahead and run this one. Most of this is written for you, but remember how we created the OpenAI embeddings. We passed that into the function. We're going to do the same thing, except for we're going to use these embeddings that are available through this model that's called Mini-LM. It's available through Sentence Transformers, another embedding model that's pretty good in open source. So we're going to create that first and define that as the function. Then again, we're going to create a different vector store. We're going to create a face vector store. This is created by Facebook. It's meant to have a different sort of functionality. It has a different kind of storage of their system, so they make lookup faster. But we're going to use the same functionality. We're going to use the same from documents like we did with Chroma. And we are going to pass in the same web chunks using this different embeddings function. And actually, I'm going to go ahead and run this because what's going to happen is Hugging Face is actually going to download this model onto your system. Also here, you'll see that I am using one of the arguments that we're able to utilize, which is this search keyword arguments, where I'm setting the number of returned documents to be 1. So here it's actually downloading Mini-LM so it can do the embeddings. After this point, it will create a face vector store of the embeddings. We'll use that as a retriever. Then we will do the same invocation, invoking the retriever using the query and getting a result. And you can see, again, in our minds, we have distinguished between the embedding model, which we use to get the retrieval results and do the embeddings, versus, actually, we haven't done that distinction yet, but what we have seen is that we're not using OpenAI here. So there we've created the retriever and we see the results. You also see that this is a good result, actually. Mini-LM open source it can be pretty good. And you see that the return statement is that the movie was released in 1977. Perfect. So now let's do a straightforward RAG. RAG is, we'll just do it. So here we have our prompt template that we're going to use. You see it's a little bit different because we're saying answer the question based only on the following context. This context variable will be provided by our retriever. And this question thing is going to be whatever input that we have. So again, we're going to start composing a chain. We have our prompt template, which is going to be this. We're going to call that RAG prompt. We have our model, which we're going to call Chat OpenAI. Make sure I run this before I forget. So now we've created that. The one thing is, in looking at these return results, they have like this structure that would be like hard for the model to use directly. And what we want to do is just take out the strings. We only want the strings to be in this context. So we just add some additional functionality. So we write this function that's called format docs. Basically what it does is it uses the page content and the metadata to create a long string. So we are going to run this one to put it into memory, but then we're going to explore a little bit of what that looks like. So you just don't have to believe me. So here what we're doing is we're calling that function on our document structure of web chunks. And what happens is you can see that this is a string as opposed to a document. And so it's going to format our documents so that they have this particular appearance. So now in creating the actual RAG chain, we need to add just so before we get to that, this is something that we've seen this whole time. Prompt going into model, going to string output parser. So what we then need to add is the RAG part. What we are going to add is something that executes in parallel, which is going to be indicated by these curly braces. What we know is our prompt is going to need at least context and question. So we're going to form the context to be input into this RAG prompt by using that Hugging Face retriever that we just made. but we're going to add some additional functionality to it. So it's now going to be piped into format docs. So after this set of two chains executes, context will have these reference documents. Again, this thing is something that the chain will call invoke on. And so when it's invoked, it'll do this retrieval. That will then go into format doc. So it's formatted and that will be stored as context to go into the RAG prompt. Then we also need the other part to go into the prompt, which is question. And that is going to come from the invocation. And so since the invocation comes first, we're going to use a special runnable indicator called runnable pass-through, which basically means, hey, it passes through this stage and passes right to this. So now at this point, we have our RAG chain. We can run this RAG chain. We can give it this name. So if you want to look on Langsmith after, you can. And then we're going to go ahead and invoke it with this. And you see our basic RAG behavior, where we went, or we would believe that it has the RAG behavior. And you can see that it went and it appeared to, look at something and then return this answer. Although we would need to go to Langsmith or use debugging to verify that. And I won't do that in the interest of time. So I can just show you this one little bit. The last thing, someone asked about running things, getting the source back. And so this is what, this is a way that you can do this, although it needs more like build out outside of it. So this is essentially, again, our regular prompt chain. We're going to break the chain that we had before in half so that at the end, what we'll have is context and question, and knowing that the context contains all of the sources. So this is specific LangChain language that's associated with this, but basically the story is we just at the very end want to be able to access the context and the question. So here we can create this. So now we have RAG chain with source. Again, this is the part that we had before at the very beginning, which does the actual retrieval and using the question. So this runs, and essentially like this just creates a new field in the answer so that we can have the answer. So now we can run this. We're going to give this a new chain so you can look at it, a new name so you can look at it in Langsmith. And now we can invoke this. We run this. And what we'll see is that we have more citation info available to us because we've printed out the context. And this is something, and we only have one result because I set that keyword at the beginning. You can also add chat history. One super last thing I can say in this 1 minute is once you start using RAG, it's super unclear. It's unclear how it's working, but LangChain and Langsmith provide ways that you're able to evaluate the behavior of the model. And you can do that. I can't type it in quite fast enough, but essentially what you can do is evaluate these strings. You pass in the prediction, you pass in the input, and it will provide you a result. And it uses a chain to do that. There are lots of criteria that you can use in order to evaluate the performance of your model. And these are built into LangChain so that you can use them directly. And then with Langsmith, you can track them a little bit better and then use feedback to work with them. In our last minute, you have homework to complete. This is a lot about the additional things that are possible with RAG where if you have challenging data or any data, then you can use these additional things to make your result better. Also, it's more depth into the LLM life cycle like we were talking about with Langsmith, and then also some practice exercises so you can look more at the document loaders, splitters, all that great stuff. All right, well, thank you so much for coming. I know we sped up a little bit at the end, but I think we made it through. Please feel free to stay for office hours and ask any questions that you need, and also talk about the homework.
And would you like to mention
I'll see you Friday.
AWS, Shara?
Oh, yeah, for sure. Do a quick reminder that on next Thursday, we do have AWS Bedrock Training Day. So whenever you are ready to create your full-scale enterprise level solution, that is what they will teach us from an AWS machine learning and AI expert that they have. Afterwards, you'll be able to use Bedrock to create your LLM-based solutions. And there are two options, in person or virtual. But if you're in Nashville, I so hope that you'll join us for in person. We'll have coffee, opportunity for networking, and lunch provided. All right, so we will now go into office hours, but please feel free to stay, ask questions, and thank you so much for coming. Y'all are so welcome. So welcome.
For the virtual for May 23rd, Charo, what are the hours? How would we get to that?
Just keep forgetting these very important things. 9 to 1. The last hour should be a lunch, like a working lunch though.
Okay. And virtual, we would just get a Zoom and listen in, basically.
Yes.
Okay, thanks.
But it'll be a lot like sort of AI Summer. They have notebooks for us to use. They've already, not already, but they will allocate us resources on AWS so that we can do like all of our exploration with different models. I think they allowed us to use Titan, Claude, if I remember correctly, and OpenAI's models. They're going to have this really, I'm just really excited at this part because they're going to talk about these multimodal models and how to do like embeddings with them, the text alongside the image. Like, I'm so pumped. I'm just so excited.
Hi, Dr. Bell. I just have like one little question.
Sure.
During the lecture, you're talking about in the collab, you said you're gonna pull from Python from Amazon, and I was curious, like, how does that work?
I so appreciate that question. Sometimes I think about pip install versus importing as two different things. And I like to think of the pip install as ordering like something off of Amazon, like ordering these Python package off of by Amazon. So they're kind of delivered to your system, but only when you import them. Importing them is like opening up the package and actually using it.
Right.
Sorry
Okay.
about that.
I was just like kind of confused. Oh, or were we like ordering from Amazon? Thank you
Good
so
question.
much.
No problem. All right, we're happy to answer any questions. Team, like I will need to jump off at 11:30 for another commitment, but please feel free to, I mean, anyone here, you can also email me if you have questions about the RAG that we've just done or completions.
Hi, Cheryl. I have a quick question. So first off, today's session was really, really helpful. Like, I absolutely loved it. My question is there any kind of resource that will help us determine what should be the length of input text and this chunk sizes and overlap? Or do we just determine that based on trial and error?
I think there is, a lot of it is empirical. Also, there are like techniques to getting at it. And some of those techniques are going to be explored in the homework. So and then if you look at so one of the reasons that I love like a lot of these platforms that are available open source is because they have that quick start in learning material. Llama Index is a really great one for this as well, and Haystack, because they talk about these different ways of approaching how you can structure your RAG infrastructure or your approach to help you with certain things. So like, for example, if you have like a lot of documents, maybe the thing to do is to summarize all of the documents and then add some metadata like we saw in the retriever so that you can put these things together to first decide what document to look at. And then within that document, you can have maybe larger chunks, which can fit into the context. So it's like, I would say it's empirical. I mean, Jesse, what are your thoughts?
No, exactly that. And if you can if you have a metric that you have defined on how successful your solution is, that's what you want to optimize up against, right? So it may really just be experimenting of, oh, when I have twice the chunk length, then the responses are more accurate, I get a higher score, and it's worth the extra expense. Because really what you're, a lot of this is, if you go with bigger chunks of the text that's going to be retrieved, then it's going to cost more when you pull it. So you're really, it's not like this is the solution. It's like, given what it will cost, is it worth it, and does it work well?
Yeah, that helps a lot. Thank you.
And Jesse's like that answer from Jesse was actually fantastic, especially in the context of Langsmith, because it is this platform which is used to kind of look at the behavior of your system and test around it. And so part of the homework again is looking at Langsmith a little bit more to see what you do in order to assess your system. And they have some infrastructure around how you can create these custom data sets and then associate like evaluation metrics with it to explore how that behaves. They also have a playground too.
Thank you.
You're so welcome.
So I've been bothering Abby about this because solidarity. I'm going to just bother the other Abby. So essentially, okay, please none of you judge me. I'm a PhD student. I promise I'm smart. So I was playing around with the brief and succinct prompt that we made, and does anybody watch Vanderpump Rules?
Yeah.
Okay, I hate okay.
Yes,
Okay, perfect. Perfect. Okay. Okay. So this perfect. So this is kind of where I am coming from. I was asking it for like, give me the summary of like that season. And I mean, spoilers, Scandival. And so, but this is what it gave me back, which I found really interesting. And I guess my question is since this is an LM model and probably doesn't pull all the time from like other pop culture things like TikTok unless I ask it to, is that why I'm getting answers like what I'm about to drop in the chat? Or is that how I can assume I can assume that I'm getting those answers because of how I've prompted it? Why can't I share this picture? I can't share a picture for some reason in the chat. Let me see.
Well, these LLM calls, so I think your intuition is right, because like this call that we're making is to like the OpenAI API.
Let's do this.
The 3.5 turbo. You should also try GPT-4 because it might provide you, or 4, what is it? 4
turbo. Yeah, 4 turbo and O. So this is what it gave me back. I was just surprised because it felt like just like this huge gap in a very legitimate social context that is important for everybody to understand. But I work with teenagers a lot, right? And I also, I think that, yeah, I'm wondering kind of if we're thinking about other ways of looking for answers with this kind of API, if we want to look at like what's happening on social media or TikTok, do we need to specify that?
I love that question. So this is still like the trained 3.5 turbo or 4 turbo Omni, but we haven't added anything else in to help it do anything. So right now, like, I guess we've added RAG today. So if you wanted to, you could, so we have that Wikipedia like web loader. You could try, because I will do this. You can use like different, a list of web loaders for like something like Wikipedia, and then the different seasons, and then use that to help with, no, serious, I'm about to do this with Star Wars. So, I mean, it's going to be really familiar on Friday. But you can use like different retrievers to look up the information and put it in context. And also there are just like straight up different tools that you can add. And we'll talk more about that on Friday, where you can use like web search, and you can ask it to like use this web search tool I mean, actually to choose to use the parameter, but essentially use web lookup to help you answer or put into context more information. So like if you say, hey, always use web lookup whenever I'm talking about any modern TV show or anything like that, then it will go and use that tool, look that stuff up, and then put that into context to help.
Okay, that makes sense. Thank you.
I'd love to get your guys' thoughts on both the OpenAI announcement and the Gemini announcement yesterday on it's hard for me to evaluate whether they're really big deals. And my son started playing around with them last night, so I'm still getting feedback from the family, but curious on what you guys expected, or more importantly, what you guys read it as.
You want me to start, Charles? Yeah, it's a very big deal. Part of the reason why it's a big deal is not for one of the big reasons that they talked about. So one of the big deals is that GPT-4o is far, far more efficient than GPT-4. It is a multimodal model, but multimodal from the core training on. So whereas GPT-4v actually sort of has a later binding from the multimodal to the text, now these models are sharing the same representation, right? And so you can get a lot more richer information from the text, and also now from audio, and also, so those are not available yet. Right now, you really are just image and text, but it's sort of built from the ground up to be a multimodal model. Another reason why it's a big deal, but not for one of the main reasons that they really mentioned, is they've redone their tokenizers. So this is really a ground up retraining of the models, and they're far, far more efficient with other languages than they were before. This means it's going to learn better in those languages. It's going to be cheaper to run in those languages. It costs like half of what GPT-4 costs right now, and it is much, much faster. So that's a huge improvement. You're beginning to see you're seeing the very beginnings of what can happen if you have multimodal models and if you have an agentic approach, meaning you have multimodal and you also are able to have multiple ways of feeding information to it. So what we're moving to is, rather than just having an LLM that knows nothing about you or about what's going on, you have something which is designed to be able to work over long context, to have a running memory of what's happening. If you think of all the tools that we have, right? So they're designed to be, again, multimodal, and to be able to much more seamlessly use all the tools that we're talking about here. So it appears as if there's a running memory that you have. But there's also a promissory note there, right? Because it's only releasing part of it. And the reason why they did that was so they could actually preempt Google, which had their announcement on the following day. And one of the similar thing, long context, similar thing with Google, and trying to make something which is more agentic, but they're a little bit more cautious with it. They don't have as an emotive voice. Theirs is much more factual. But what Google has that OpenAI doesn't yet have is extremely long context models. So with their Gemini model, they're getting up to 2 million tokens now. So imagine everything that we're talking about. We're talking about, I need to make the chunks small, right? So they can all fit in context. Well, what if you have 2 million tokens, right? And it's like, okay, now you put in much larger chunks of documents. I'm writing a paper with two folks that are in completely different areas than me right now. And what I'm doing is I'm taking a bunch of the articles that they say are the most important ones, and I'm putting them all into a single context, and I'm reasoning against those. That's the kind of work that you can do with long context models that you can't do with others. So that was a big advance. They also announced Gemma 2 with additional changes in architecture and capabilities. Those are fully open source, really important for researchers to have those. And then the promissory note that Google had was an agent platform, which is not available yet, but the idea is that it's like from scratch an agent platform, which I think they're calling Astra, which they're hoping to be able to release later as well. So we've been in the age of these basic simple building blocks. You're seeing how we can build these other things with it. Now you're having LLMs that are much more efficient, cheaper to run, much more capable, which are designed to always be part of the system that are meant to do multi-step tasks of solving your problems. Whereas right now we have to handcraft those. Now it's going to be, you just get that as table stakes, and then we can build other stuff on top of that. So that's my take.
Crazy. Wow. Just so I have the terminology, Gemini is not open source. Gemma is open source.
Yes.
That's sort of like it's sort of like their premium model, effectively. If you think of other, like LinkedIn or something, they have the free version and then you pay extra.
Yeah.
I guess the question, I was thinking last night with a friend, texting him, it's like, in what respect, why am I going to still pay $20 a month for ChatGPT 4 if ChatGPT 4.0 is better, it sounds like, in all respects?
Well, you'll get, if you're paying, you will get more turns on GPT 4.0. So it's not that you're just paying for GPT 4, you're paying for the plus chat. That's going to get you, yes, everyone will have some access to GPT 4.0. That was sort of the idea, but you'll have more turns on it. And I'm starting to use it everywhere. You know,
The 4.0, you're saying?
and I'm starting to use the models everywhere, not in API calls, which is a separate expense, but being in a talk and wanting to take a picture. The next step is, once we do have the audio, more simply, is to when I'm in a lecture. I did this with an organic chemist talk. You know, being able to get immediate feedback, especially with the latency being as low it is. And the only way that I can get all those turns and take all those pictures is if I have some sort of plus subscription, so I have that kind of access to it.
Okay.
Yeah. So that's why you might want that, because it is going to be more limited if you don't have some sort of plus subscription.